Yep.
Great. Uh, Hello, everyone. This is Sam from Real Smart Economy. Today, we are glad to invite Michael from Axlabs to give a workshop called Coding Smart Contracts in Java. Hi, Michael. Could you please introduce yourself first, and
Hello,
you can
everyone.
start your workshop.
Hello, everyone. Welcome to the workshop about coding smart contracts in Java. My name is Michael, as Sam told you. I'm a software engineer at Axlabs. Quickly about me, I have a Master of Science in Informatics at University of Zurich. 1 second, I get feedback that there's a terrible echo. Is that the case? Or it's fine?
It's fine.
It's fine, okay, sorry. I've worked for Neo for 3.5 years, since really the beginning of 2020. I'm now responsible for the Neo 3J development, and also a little forecast. I'm currently working on a new exciting project related to Neo. And just a hint, it's about setting up nodes more easily. So about Axlabs, Axlabs and Neo, Axlabs been a member of the Neo community since about 5 years. We first started with the Neo 3J Java Kotlin SDK to interact with the blockchain through Java. And since 2019, we've started and we're maintaining a dev pack to compile smart contracts in Java. 2 years ago, we started the GrantShares DAO, implementing it, and also we're a member of it. And actually, since day one of N3, we're also a council member in the Neo governance. So here quickly about some projects that are using Neo 3J, for example, the SDK to transfer tokens, for example, Binance, OKX, GrantShares in the backend, of course. Then some well-known audited smart contracts that are on mainnet is GrantShares contracts. It's actually 2 contracts. It's a DAO. Then the FUSD, the stablecoin from Flamingo, it's a NEP17 token. Then Cineo, a DeFi project for compounding token rewards from the Neo token. Also a NEP17, and the Candy token, NEP17. Yeah, we have about 6K plus downloads per month. So here quickly about the workshop, some prerequisites first, which things you should know when watching this workshop, and some capabilities and limitations of Neo 3J. And then we're directly diving into the development, getting started with the environment, then quickly about storage, access control, how to control who can invoke certain things on your contract, or what other contracts can take part, can invoke some methods in your contract. Then how do you receive payments? NEP17 tokens, or also NEP11, the NFT proposal, like the standard. Then how to configure your deployment configuration in your contract, and if you want to update your contract, how you can migrate some things. Then about permissions and invoking other contracts from your contract, and in the end some metadata. So you should already be familiar with what is a private public key pair, what is a blockchain, and what is a smart contract. Yeah. So if you're not familiar with these, please check these terms first and then come back and have a look. So you don't need to reproduce my coding steps live because it's recorded. So if you're not familiar with the terms, go read about them, come back, and you can rewatch everything. So Niao3J, the dev pack, can compile smart Java classes to Neo smart contracts. So what the compiler does technically is we compile the Java classes into JVM bytecode and then transpile this bytecode into NeoVM bytecode, which is then deployable to the Neo blockchain. So this Neo bytecode will then be a NEF file, which is the standard in Neo. Then you can interact with Neo blockchain with Niao3J. So when you compile a smart contract, for example, and we want to deploy, you will need the SDK, and you can send a transaction to deploy this contract, for example. And we also have a test framework, so you can easily test your smart contracts as much as you want. I suggest to test everything because you want to be sure about what your smart contract does if you deploy it. About the limitations on Niao3J, it's using a subset of Java, so there are things that cannot be used. So please check out our documentation about this. We have a section that we call Niao Java, where we explain these things in detail. And for example, you can't use math at random. Yeah, and there are no floating point numbers. So yeah, let's dive in. So when you first go to Niao3J, to our GitHub organization, you see a lot of repos. Here's the Niao3J, the main library. Then we have some docs, which we show under niao3j.io. Then we have a repository for various extensive examples about the dev pack, smart contracts, and also the SDK, of course. Then here's still the workshop repo from the last hackathon. We'll replace this with the new one, with the APEC workshop afterwards. So you can come here and see what we coded in that workshop after this workshop. Then we have two public templates, one for the SDK and one for contracts. So you can come here. Then if you want to get started your own, you use this template. I suggest you create your own repository. Here you can choose templates, and you choose this one. You say my new contracts. Let's make this private. You create it. So you have your own project. And then here you can either develop locally. Sorry. You can either develop locally, of course, or you can also use code spaces from GitHub. So you can go here and create a code space on main. What this will do, it will create a container with an integrated VS Code interface in your browser. So you don't have to do anything about what is working behind it. It's just everything pre-installed, so it's quite nice. What I'm doing now in the workshop is actually I'm using my local VS Code. What you can see here, this is basically the same as in the browser. The only difference is that here I'm running Docker, which you'll also need to test your contracts. And I'm running this in a Docker container basically, and the VS Code just displays this. So you don't need to install whatever you like. So when you start your VS Code with this template, there should be a pop-up about the dev container here, and you should be able to start this in a container. So here we are, quickly about the structure of this template. So you have here source, then you have main, which is the place where you put your smart contract classes. For example, here, simple contract, I'll get back into that. Then we have test. And here you have the tests you want to write, for example, to test whether something actually is whether the contract actually does what you intended to do it. And then we have deploy source set here, which is just a nice way to collect your configuration for mainnet deployment specifically, or also testnet, of course. Yeah. So 1 second. So yeah, then let's start with the first simple contract. So here we have a class, simple contract, just basic Java class. And let's say we just want to get a fixed constant value, a get method. So you'll make a public static class, and let's say you want do you want maybe a string get, and you return hello world, right? So that's already your first method, and this contract is already compilable. So now what you can do to just compile this contract and get the nef and the manifest and also debug information, you can use Gradle, 3j compile. Sorry. Of course, before doing that, you need to go here and you need to specify here in the build Gradle, the Meow3j compiler, the correct class name, which is simple contract, right? Then you run this command again, and this should compile your contract. And then you can go into build, and in here in Meow3j, well, I already compiled some contracts. So this is the contract, and here is the manifest. You can see here ABI, the methods. There's one method. It's get. It doesn't have any parameters. It's the first one, and it returns a string. Yeah. And here's the nef, which is bytecode, so you can show it. And yeah. Great. So now let's say you want to test this, whether get actually returns hello world. Then you can go to test and you can write a simple test. Let's get this out the way. So how a test looks is you have just a class, then you register an extension. You can just copy paste this code when you do a test, like these lines here. Then you use the annotation at contract test. You can specify the block time and you can say what contracts you want to have deployed. So in this case, we want a simple contract class to be deployed. So once I run some tests here, it will start a Docker container with NeoExpress in it. And in there, it will run a new blockchain. It will deploy your contract, and it will invoke your contract as you specify it in the test. So this all happens in a Docker container. So there's no infrastructure that you need additionally to just running Docker. So let's write a test. Test get, right? Now we have here the contract. Then you can, now just to note, now we're using the SDK. So here we're no longer developing a smart contract in that class, but we're just interacting with the blockchain, with the new blockchain. So here you can call invoke function. So just to mention these two different, if you use invoke function, you will actually set up a transaction that will persist on chain. So it will cost gas, and you will need to have some address that signs this transaction and has gas to pay it. So if you just want to read, which in this case we just want to get this value, so we don't want to change anything on chain, so we can just use a call invoke function, which is just another RPC is used for that, and it doesn't cost gas, so you can just read what is there on the chain. So you could do call invoke function, or because we already know that what's returned is a string, we can use here some utility methods we have in the R3J, which is call function returning string, which already processes what's returned and converts it to a string. So if it's not a string, it either fails because Java cannot convert it to a string, or you will have some value returned that might not exactly express what you want. So make sure to use this when you know that the string is returned. Otherwise, let's use another one. Let's use call invoke function. So you have the function, it's called get, right? We have no list, an empty list. Let's quickly import this. Yeah, it's just an empty list, and we don't need any signers. So this returns the neo invoke function. Okay. Result invocation result. Right, to import these classes. 1 second. What's the problem here? Oh yeah, of course. Right. So now we have the result. What can we do with this result? We can get the stack items, which is what is returned, and you can get some other things. You can check this out in the class invocation result. So this shows what is returned when you invoke that. So what we want is we want to get the first stack item. Like, first of all, we want that only one stack item is returned, right? Get stack, assert that size is 1, right? I use that in another one. I think it's here. Sorry for that. Let's use equals. Right? And then here we want to assert that this this first stack item gets type is a string. Let me check this is. I need that. Here it is. Hamcrest matchers. Get type is can check what it is, stack item type. That, and then you want to use the string. Sorry. Let's just check what it will return. Yeah, we need the Jupyter. It's AI. Let me quickly check. Sorry for that. It's Hamcrest as well. Great. So now we can run. One second. Maybe we need to reload the window here. Now it's reloading what is running in the Docker container. And sometimes this takes a while. So then you can basically test that when you call this get method, you can check actually what is returned and check and verify that this value you want to return is actually returned. So it takes a while. So let this run for now. Let's go back here. So let's say you want to use not a fixed value, but you use a static variable. You can do that as well. So you can use this, let's say an int, and we want F42. You can, this is really nice if you use a value multiple times through other methods, then you can use a static variable here and use that multiple times. Public static int get static return static var, right? And then now it should work. It's worked before. Somehow it doesn't seem to take this test. It's probably still loading somehow. It's weird. Let's close everything here. This is it. Sorry for this, guys. This just worked fine just before. Don't know why this is not working right now. Maybe I should reload this again. I'll just reopen the full thing. Give me a second here. So here, as you see here, when I reopen this, I get a pop-up reopen a container, which is what I want to do. And now it starts a container, it reloads the window, starts a container where I can where this whole VS Code instance is served with all the extensions that you need. So this is just an interface to what is going on in this Docker container. And this sometimes takes a while, but it works really nice because you don't need to change anything on your local device. You don't need to install anything other than just Docker and VS Code, which is really neat. But it can take a while. So to not get blocked here, I'll come back to the tests. Usually what should happen is I should see a play icon here in the test as well. You should be able to click that and then the test runs. Or you have this one here so that the whole test runs, like every test that is in this class will run. Yeah, so let's go back to the contracts. So what I want to show next is how to interact with storage. So what a contract can also do, instead of just returning static values, you can access a storage context of a contract, and you can modify this context. Kind of imagine a database for your contract. So what you can do is you can put something, you can get something, and you can delete, or you can even find it, which is a bit advanced, so I don't think we have time to go into that. You can read about iterators in there. If you want to find something, it's basically to scroll through an array of like if you have 10,000 users and you store their ID and their power values or whatever, you can use find to find specific values that basically, for example, as a filter, or if you want to retrieve all of these 10,000, you can't retrieve everything all together because there are limitations to remote procedure calls, RPCs. So you use find, you get an iterator returned, and then you can call another RPC multiple times to traverse this iterator to get like 100 entries per call. So you just call it 100 times, and then you have all your 1,000 users with their power values. So let's just write a put method. So put something, and then you maybe want to use an int as the key, and you want to, let's say you want to put any value. I don't know. Let's say yeah, just any value. Then what you do is you use storage put. And now you need for this method, you need to provide the storage context of your contract. So how should I say that? You can access your context in different ways. So you can access your context in a writing mode, where you can update what is in your context, and you can also access it in a read-only mode. So here we want to write, right? Get storage context. So this is how you get the storage context. Since you're using that probably, like if, for example, here we will use this context in every method. So you can specify it in a static method, in a static variable on your root level of your contract. This is also the area which will be loaded regardless of what method in your contract you invoke. Static variables will be loaded anyways. Static storage context, then storage that. And here you see we have storage context and read-only context. But of course we want this. Let's say we do read-only as well. You can, of course, you can also read with this one. So you can also use this one and make sure you have the according restrictions set yourself. So what you want to do here is key value, basically. And that's already it. If you invoke this method, you can put something in your storage. And if you want to get that, void get something, you can just provide the key. You can return. Of course, this will not be void because you want to have it returned. Fpack, then storage get context key. Right. Of course, here we can also use the static context. Also, another thing which can be nice, if you access everything is byte string. So if you store here an int, you already know, okay, I will get here an int. So you can use a utility method of Neo3j. You can use get int, and then this will also return an int. All right. So when you want to put more complex information, for example, here it's just an integer, right? Let's say you wanna put multiple things. Let's say you want to have a name, a string, name, and then an int, some age, and an int, some power. What you can do is you can create a struct. So I created here a struct class. You can also create this in here as a static class. Let's create it as a static class in here. Maybe static class my struct, and then you just name int age, int power. And now you need to tell Neo3j that this is a struct. So you use this add struct annotation. What you can now do is let's call this feature. Public static void put struct. And then you can say feature. I don't know what's wrong here. 1 second. Maybe just, no. It's this. Yeah. Okay, so now you can obviously, you can't just store this because the storage put method only accepts specific values, like int hash 160, just the types that exist on the Neo VM. So what you need to do is you need to parse this feature into something that matches Neo VM. So let's just quickly here convert feature to Neo VM compatible type. So here you would do context key and then compatible, right? Of course, here we need the key as well. So what you do here is you will use a native contract on Neo, which in this case is the standard library contract. You can use and you can invoke that, create a standard library like this. And then here you have several methods. For example, ASCII to int, base 58, check, code. And here we have deserialize and serialize. You can see that, but somewhere. Let's use serialize. I use feature. And this will return you a byte string. So you can use that, and then your feature is stored as a byte string. So when you read that again and you want to handle your struct, you can even do this. Get struct int key. And then here you do storage get, because remember you get a byte string now. Context key. Compatible like this, right? But now you need, of course, you need to return a feature. So what you need to do is you do this and you use deserialize. And since we're in Java, you can just do cast this to feature and it's fine. So what will happen if you test this? It would be a good exercise for you to write a test. I think I already wrote one, and I'll show you in a second. This will actually return, if you invoke this get struct method, will return an array, like a stack item, which is an array, and it has 3 entries, like here in that order. So you will get one stack item of type array, and in there you have 3 items. The first one will be the name, the second age, and the third the power. So that's how you can store more complex things. It's actually here. So yeah, let's continue to access control. Let's say you want to have only your private key, your private public key pair to access this contract. It's your contract and you want to manage what funds it holds or whatever. Then you can write an admin function, for example, or get owner. There's actually currently a proposal about NAB standard for owners. So let's write quickly method static Boolean has access. Of course, you wouldn't just write a method has access, but you just to show you. So what you use here is you would use a runtime, and here make sure you take the runtime of our dev pack and not from java.lang. With this, and you do a check witness. So what this does is it checks whether the provided script hash that's provided here in the parameter script hash is allowed to do anything. So let's say you want to put something. Let's copy this method over. Of course, here read only context, and here as well. Let's go back here. Let's say you only want you yourself. Let's say you have some address. Let's get some address here. Access contract here. Hash 60. So this is, let's say this is your address and it's fixed in your contract, and you only want that only you that owns this address, access to this has access to this address, want to be able to store something in your contract, right? So what you do is you do the check witness in here. Let's make this private, so it's not actually a method that anyone can invoke, but you can use this method within other methods that you have here. So you can do here if has access admin, then do something. Usually you should do this if doesn't have access, you throw an exception. Right. Yeah, of course. Another thing, another takeaway here, you can only use the class exception in our Java dev pack. So when you want to throw an exception, you can just use this. You cannot use any custom exception classes. So if you don't have access, meaning there's several cases now. I wrote down a list of what actually this means. Let me take a second. So here it is. So there are some cases about this check witness, about what this hash 160 represents. So it could be a normal address, which means it's private public key pair. So this check witness will return true if the transaction that ultimately invoked the method that led to this part of the code, if this transaction has this address, this script hash as a signer with a witness, with a signature. So then it will be true. It will check this. Then what it will check is if it's a multi-sig address, it's true if this transaction has enough of this multi-sig addresses if it has enough signatures in the transaction. But this script hash could also be a contract, right? For which the private key is not known, right? So it's a special case, and then what is checked is whether this contract is calling this method. So let's say I have another contract which orchestrates some things, and I have this contract where I want to store some specific information, and I only want that this other contract can change the storage here. It will check whether this contract A is the one that is calling this method. If that's the case, true is returned. And otherwise, if it's a contract, but it's not the one that's calling this method directly, we'll call on verification, which is another method that contract needs to pass this check witness. So you can use the annotation on verification, and then here you can see you can read that further. Basically, what you need to know is that this verify, you need to sorry. So this verification needs to have some certain let me give a minute. So let's say yeah, sorry. Here you, for example, want to have has access, right? I don't know why this doesn't work here. No, it should work. So yeah, but this of course would be on the other contract, right? So when this is called, it would call this in this other contract, and then in that contract that probably also has a method has access or is allowed, is authorized, whatever you want to call it, and you can use that there. Yeah. So let's go to next. What's next? So now receiving payments. Let's go here. So let's say you have a contract and you want to receive NEO on the contract. So what you can do is you use the annotation on NAP 17 payment, right? Receive, and let's say you want to receive everything, you just do nothing here. What you need this method to have is have this structure: void, any name, sender, and amount and data. So you want to have hash 60 from amount data, right? So in here you could do some checks if from is not new token, that's script hash, right? Let's make sure this one is used. I think it's this one. Yeah, get hash is not return throw exception, for example. Actually, we should read about the standard. I don't know by heart whether we should throw an exception or return false. but you can read that in the NEP proposal about in the NEP 17 standard. So here you can control what you want to receive. So and what you want to do. As an example, I think the BNEO contract or also the CNEO contract, how you get tokens is by sending tokens to that contract, and it will trigger this on NEP 17 payment. It will check, is it like in the CNEO contract, for example, is the receiving token, is it BNEO? If so, okay, then I have now more BNEO and I'll mint CNEO for you and allocate it to you, to that address that sent it, right? So you can do these things in here. Then, of course, there's also the on NEP 11 payment, which is pretty much the same. Void receive NFT. What's different here is, I think, I don't know the structure here. It's sender amount and then token ID. You need to add a token ID. Amount and object data. Yeah. Yes. I think it's byte string, right? Yes, it's byte string. Yep. So that's how you can receive tokens. Then the next thing is about permissions. Let me, here it is. So if you another contract from this one, you, let's say you wanna, we already did that actually. We did it in storage. Here we called the standard lib contract, right? And the thing is, this one is a safe method. So you don't need any permission for that. You don't change any storage in this standard lib. So you can just do that without any thought, like it just is a function that does something for you, but it doesn't affect it. Whereas, for example, if you transfer NEO token, you change, obviously, the storage of the NEO token contract because the balance needs to change, right? Someone is sending tokens to someone else, so it should be reduced at some address and increased the balance and should be increased in another, right? So if you want to do that, let's say you want to transfer tokens to an amount, you use new NEO token. Make sure you use the one from the dev pack here, because here we use the SDK and the dev pack, and we have a NEO token in both of those. You invoke this method, and you basically have everything. You don't want to add any data. Here, the from should be this contract, because this contract is transferring it, right? So you can use runtime get executing script hash, which is this contract, right? So now if you compile and test this contract and you invoke this transfer method, it will fail, because by default, this contract doesn't have any permissions. So you need to add a permission native contract. If it's any other contract, not a native one, you can use contract with the address. Here we have a native contract, which is the NEO token, right? And if I leave it like that, everything is allowed on the NEO token. So this contract is allowed to invoke any method on the NEO token. If I want to restrict that, I can I can add the methods here. Let's say here transfer, right? But let's leave that away. So now this will pass. Although, if you know the governance system of Neo, whenever there's a balance change with Neo, there is gas distributed. So basically what you're doing here, you're sending Neo from this contract to another address, be it another contract or just a private public keeper, doesn't matter. So that means this contract held Neo, meaning it should get gas once its balance changes, right? So if you send Neo, gas is collected, and to accept it, you need the on NEP 17 payment. Otherwise, it will fail, right? So you do this, static receive, right? And once again, check what it needs, sender amount data. Amount. It needs to have that structure so that others know what to invoke exactly. You don't need to actually use them, right? So what you want to do here is, for example, you only want to accept Neo and gas. If 1 second, sender. So here the Neo token will call this, right? So you want to use the get calling script hash. Get hash, right? Like if it's not this, we will use that again. So let's do this hash 160 calling script hash. And calling script hash is not equal gas token. We throw an exception. Right, of course. Right. So now we make sure that this contract only receives Neo or gas. For example, if you want to send Neo to this contract here, it's not going to work because this check here will fail and an exception will be thrown, right? Great. So I think we're heading to the last part, or second to last. I think it's deploy and update. So let's go here. So another annotation on deployment. So for example, if you don't want that your owner, for example, here is fixed in a static variable, because you can't change this address afterwards. But let's say you want to make it update, like you want to be able to change this, right? What you can do is you can store this address in storage instead of a static variable. And when it's in storage, you can change it. So what you can do, it's here. You can say, okay, on deployment, what does it say? What do I need here? It needs to be void, any method name, data, and is update, right? Public static void deploy or update, right? And it needs data and a Boolean. So now you do a check here. If is update. You can, for example, migrate storage or whatever you need to do. Make sure you return, because otherwise you continue here. And here, the deployment. So here, for example, let's say we want, let's jump up over to the storage and let's quickly save an owner. Let's take this. Then let's get this right. Here, it doesn't really matter. What you could do is you can also do this to have the read-only context. You can set owner. Then you can say, okay, hash 160 owner. And the owner key, we will store that in a static variable. Right? Let's say we do that. And here, what we want to do is we want to restrict that only the current owner can reset this owner, right? So here you want to do a witness check. Again, not using the Java long runtime. Check witness. Like this, maybe we call this differently. New owner, right? Right. And then we need a method. Get current owner. And we return storage get hash. It's hash 160 owner key. Like this, right? So now if I want to set a new owner, then the current owner needs to witness this transaction. As said with this accent, you can check the access control for this again. And then you put it. Right. Of course, here you wanna, if check witness fails, throw new exception. Right. Throws exception, right. So in here, we want to set it. Initially, it's not set. So we want to set it when you deploy the contract. So what you do here is storage put context owner key, and then this data here can be anything. It can be an array, it can be a map, it can be just a byte string, and it can also be just a hash 160. So we cast this to a hash 160, and we put this, meaning when you deploy your contract in the SDK, you can call deploy, and then you add the nef, you add the manifest, and you can also add data. And this data is what is this here. And if you don't add data, then you just don't have any value here. or there's not even on deployment method specified here. We'll create one for you, an empty one anyway, and just nothing will happen in the deployment specifically, right? But here you just set the owner, and then you can reset the owner here by passing a check witness, and you can retrieve the current owner. And yeah, if it's an update, meaning that you want to update your contract, how you do that is public static void update contract. So what you do here, you probably want to take the nav and the manifest of what this new contract should be, right? So what the bytecode is, but this will change automatically if you update the contract. The nav will be the new bytecode, the manifest will be the new manifest, right? But the storage itself persists, so you will need to migrate storage in here if necessary. Depends on how you develop your contract. So what you need to do here is you need to call a native contract, which is contract management, right? Update. And then as you see here, you need the byte string nef file, a string, the manifest, and some data if you want to use data here in the update. If not, you just don't, right? So what you do is nef file manifest. Oh, right. And since this updates storage, as far as I know, again, back to the permissions, you need to give this contract permission to be updatable. So you want to add the native contract management, right? Of course, if you want to have another permission, you can just copy this line and do another permission for a new token, for example. Yes. So this, and the final thing I think is metadata. So if you want to use some, for example, in Java, some protected names, then you can name your contract manifest extra. Actually, I don't remember by heart how to name the contract. What you can do here is key, say author value Axlabs, right? And contract name, I think, let me check quickly. Last thing. I think it's just display. Yeah, actually, guys, I'm not completely sure. Ah, here, yeah, it's just display name. Display name. Right. So if you compile this, the nav will not be named deploy update contract, but it will be called my contract. Let's go quickly here. Change that. Right. Compile. And you will see here that it's not named deploy update contract, but it's named my contract. here, my contract.nef, right? And my contract.manifest. Yes. Also, another thing, just add some things. This is not metadata, but if you support and if you want to develop an NEP17 contract, you can use supported standard, and you can use neostandard.nep17, for example, right? This will be added to the manifest. Yes. I think I covered several things. One last thing I think I could mention is event. An event, let's check quickly where I have one, then I can just copy paste it to you on transfer. Yep. So an event you can specify as a static. Let's say I want to fire an event if a new owner is set. Then I might want to use 2 arguments on ownership transfer. Then you use this. Second, you need to import it, of course. Here, when setting a new owner, that fire, then we have, well, you can just use the new owner. Let's just do this, right? I do here 1 arg. I think it is. Exactly. Yeah, of course, just 1. Nice. So now if you invoke set owner and it passes check witness, this event will be fired and will be showed in the application log. So yeah, that's it. Sorry, I spent some more time here. Yeah, I'm ready for any questions. Maybe Sam can tell me
Hi,
if there
Michael.
are some questions.
I think there is no questions, but there is one thing I need to mention. I think the network from your side is not good enough, so there is a little lags during the workshop. So if you have time, you can record a new workshop video, and I can help upload the new videos with more smoothly motion.
Sorry, I didn't get the last part.
I think if you have time, you can record a new video about this workshop. I can help upload this video to replace this live streaming. And I think that will be better
Yep.
for the users to learn how to code smart contract in Java.
Yeah, you can think about that.
Okay,
Otherwise, I would
great.
just add specific chapters for this topic so they can jump around this
Yeah,
video, right?
yeah, right. Yeah,
That'd be
great.
great.
Thanks for your time.
All right,
And this is, I think this is the end of this workshop. And thank you, everyone.
great.
Bye-bye.
It's great having you.
Great.
Yeah,
Bye-bye. Thanks.
goodbye.